Hello friends, today's question. In the figure, the block A of mass m1 rests on a rough horizontal surface. The coefficient of friction between the block and the surface is mu. A uniform plank B of mass m2 rests on A. B is prevented from moving by connecting it to a light rod R which is hinged at one end H. The coefficient of friction between A and B is mu. Find the acceleration of blocks A and C. So we have three blocks A, B and C. A and C are connected with the string, whereas the block B is connected with the rod so that it is not able to move and it is on the top of the A. And we have the coefficient of friction here is also mu, and at this place it is also given as mu. So we are going to find out what will be the acceleration of block A and C. So let us find out, let there be tension T here and this will be tension T. Okay, and other than that, let's draw the free body diagram for each block. We can say that for block M1, so first there will be M1G in the downward direction and there will be normal because of the contact surface, and let us call that N1. There will be tension T, and we assume that M1 moves in this direction with the acceleration A and C moves, that is M3 moves in the downward direction with the acceleration A. Okay, so the acceleration of M1 is A towards right. So there will be a force of friction, that is called as FR1, between the M1 and the tabletop or horizontal surface, and M1 is also connected with M2, or M2 is lying above the M1. So there will be also a force of friction because of M1 movement of M1 with respect to M2. Let us call that FR2. So let's define our FR2. FR2 will be because of this M2. This will be mu M2G, and our FR1 will be a total weight will be M1 plus M2 and multiplied by G. So these are our frictional forces which will be acting on M1, and now we can write the equation. It is moving towards the right with the acceleration A, so we can say that T minus FR1 minus FR2 is equal to M1A. We already know value of FR1 and FR2. We substitute it here, so we get T minus FR1 is mu M1 plus M2G, and FR2 is mu M2G. This is equal to M1A. We further can solve it. This will be T minus, taking mu G as common, so this will be M1 plus twice M2 is equal to M1A. Let this be equation number 1. Similarly, we can write for block C. Okay, so this was block for M1, which is A, and similarly we can write for block C. Block C whose weight is m3, and its free body diagram. So this is our m3. m3g will be acting in downward direction, and there will be tension T in upward direction, and we assumed it is moving with acceleration A in the downward direction. So we can write the equation of motion that T minus m3g is equal to m3a, and this is equation number 2. So we add equation number 1 and 2. Adding equation 1 and 2. So let me write equation 1, that is T minus mu g m1 plus 2m2 is equal to m1a, and we have equation 2 as, sorry, my mistake, it should be m3g, let me write minus and plus, okay, because it is moving in downward direction. Okay. So this will be minus t plus m3g is equal to m3a. So we are going to add them. T cancel out with t. So we get this as equation as m3g minus mu g m1 plus twice m2 is equal to a m1 plus m3. So let me once again write the equation. We got the equation as m3g minus mu g m1 plus twice m2 is equal to m1 plus m3 multiplied by a. So we get the acceleration as a, it can be written as m3g minus mu g m1 plus twice m2 divided by m1 plus m2. So this is the acceleration of block A, whose mass is given as m1, and block C, whose mass is m3. So this completes the question. Thank you.